Hello, Algebra 1 students. This is going to be the second half of the 4-1 video. Let me just get to the page here. So this is 4-1 day 2. We have a warm-up there. I'm just going to say maybe pause the video and do that warm-up, and you can get that checked when you are in class. We have a little reminder here of some of your formulas. So this is slope-intercept form, and this is slope-intercept form. This one is written in function notation, f of x, that identifies your output. This is the one that you've seen a lot of, y equals mx plus b, but those are the same, just a different way of identifying your output. And this is your slope formula. Hopefully you have that memorized by now. And just a reminder that that is also rise over run, or change in y over change in x, and it's a rate of change. Okay, write an equation of a line that passes through these points. So what do we need to write an equation of a line? We need a point and a slope. Well, we have 2 points here, but we don't have a slope. But we can find a slope if we have 2 points. We can use our slope formula to find the slope using these 2 points. So m equals, draw your fraction, put your subtractions on the top and bottom, and then remember, I recommend when you're using the slope formula to write your points on top of each other like this. Then your y's are lined up and your x's are lined up. So my y's are 4 and negative 4. My x's are 8 and 0. Okay, minusing a negative is the same as adding, so this is actually 4 plus 4, which is 8. 8 minus 0 is 8. 8 divided by 8 is 1, so my slope equals 1. So that's important. I'm going to use it later, so I'm going to give it a squiggly underline. Find the y-intercept. So remember, when you have a y-intercept, I'm just going to slide up here to show you, this is a y-intercept. Whenever you have a y-intercept, a point on the y-axis, your x will be 0. Because if you start at the origin, you don't go right or left, you just go up or down. So y-intercepts are always a coordinate point where x is 0. So this right here, 0, negative 4, is your y-intercept. So 0, negative 4 is your y-intercept. So in slope-intercept form, we call the y-intercept b. So over here, I'm going to say b is negative 4. So now I have a point, which is my y-intercept, and a slope. So I can write an equation of a line in slope-intercept form. Y equals mx plus b. My m is 1, my b is negative 4. So I'm going to have y equals 1x minus 4, which is good. Even better is y equals x minus 4. So same thing that we did in part 1 of 4-1, except one extra step. We actually have to find the slope. So this one is for you to try. So I would like you to pause the video and try this one. Okay, hopefully you paused and tried it. If you did, this is what you should have gotten. You should have gotten a slope of 4, a y-intercept of negative 7, and that is your equation, 4x minus 7. Okay, let's do another one. This is the same, really, except, you know what, I'm going to try turning my light on, see if it helps make this a little brighter for you. It helps a little. The only difference here is they have written the coordinate points in function notation. So remember, f of x, this means when x is 0, y is negative 5. Excuse me, my phone is chirping over there. F of 4 equals negative 3 means when x is 4, y is negative 3. So step 1 says write as ordered pairs. So write your function notation as ordered pairs. Well, f of 0 equals negative 5 is the same as 0, negative 5. F of 4 equals negative 3 is the same as 4, negative 3. Now it says find the slope the y-intercept and write an equation. So slope, I'm going to do that first. M equals, put your subtractions, My y's are all lined up here, so this is -3 and -5 are my y values. My x values are 4 and 0. This is the same as -3 plus 5. 4 minus 0 is 4. -3 plus 5 is 2 over 4. Simplify your fractions. That is 1/2. So I'm just going to put this over here. M equals 1/2. That's important, and I'm going to use it when I write my equation. My y-intercept is this coordinate point right here. Because the x is 0, I know that is my y-intercept. That point is on the y-axis. So this means my b is -5. All right, I'm going to write that over here. Because that's all I need. Y equals mx plus b. My m is 1/2. And my b is -5, so that will look like y equals 1/2 x plus -5. Y equals mx plus b. This could be simplified a bit. Plus -5 is the same as -5. Okay, so that is an equation of the line, but this says in step 6, so I'm going to rewrite my equation over here. Because we started with function notation, we want to end with function notation. So in function notation, the way I identify my output or my y is I say f of x. So this is writing that equation in function notation. So this was good stuff. Y equals mx plus b. In function notation, it would be f of x equals 1/2 x minus 5. Okay, we're going to do one more here. So right away, I'm going to think f of -5 equals 5 means when x is -5, y is 5. Remember, this is saying plug -5, x equals -5, into function f, and what will your output be? Your output will be a 5. So this point as an ordered pair will be 0, 10. And right away I'm noticing, ooh, 0, 10, that is going to be my y-intercept. So I'm actually going to go down here, and this time I'm going to find my y-intercept first. And it is 0, 10. I know that because the x value is 0. So over here I'm going to say my b is 10. Okay, now I have to find my slope. So slope is a fraction, rise over run, y2 minus y1 over x2 minus x1. These are my y's. Those are going to go on the top. These are my x's. Those are going to go on the bottom. 10 minus 5 is 5. Remember, minusing a negative is the same as adding, so this is actually 0 plus 5, which is 5. 5 divided by 5 is 1. So m equals 1. All right, let's put those into slope-intercept form. Y equals mx plus b. Y equals m. My m is 1. X plus b. My b is 10. Okay, that's looking pretty good. But step 4 says write the equation of your line using function notation. So instead of y, I'm going to replace that with f of x. And then this time I'm not going to put the 1, x plus 10. When the coefficient is a 1 or a -1, we typically don't write the 1. If it's a positive 1, we just write x. So f of x equals x plus 10. Okay, your turn. Pause the video and try this one. And this is what you should have gotten for that one. F of x equals -x plus 5 should have been your final answer. You should have gotten a slope of -1 and a y-intercept of 5. Okay, we got another example. Day 2 is a little longer, isn't it? Okay, this is a graph that gives us some information. So this says The graph shows the price of a smartphone plan. So it looks like this is how much data I use, and this is my cost. So for example, this coordinate point right here means if I use 2,000 megabytes of data, my cost will be $80. Now the first part says, what is the y-intercept? That is the y-intercept right there. What is the y-intercept of the line? It is 0, 20. Then it says, interpret the y-intercept in context of the problem. So the context of this problem is data usage and cost. So I want to make sure I'm talking about data usage and cost. So this is x is 0. So that means my data usage is 0, and my cost, the y, is 20. The cost is 20. So if I'm interpreting this, I want to say basically what I just said. When data usage is 0, the cost is $20 per month. When data used, I'm going to say used, is 0, the cost is $20, and then this is per month. You could also say when you've used no data, the cost is $20 per month. So that's kind of like a starting fee. You're paying $20 per month even before you start using data. You could also say at the beginning, before you started using data, the cost is $20 per month. This says approximate the slope of the line and interpret the slope in context of the problem. Well, I have 2 coordinate points here, so I'm going to use those to find my slope. So that coordinate point is 0, 20. That coordinate point is 2,080 is my y. So all I need are 2 points to approximate the slope. It actually won't be much of an approximation. Well, I guess it will be. So 2,000, 80. So I'm writing my 2 coordinate points on top of each other. And my slope will be, put my subtractions in there, y minus y, 80 minus 20, over x minus x, 2,000 minus 0. 2,000 minus 0. 80 minus 20 is 60 over 2,000. Simplify that, you get 6 over 200. If you turn that into a decimal, you get 0.03. Okay, that is my slope. Now I want to interpret that in context of the problem. So a couple of things you want to remember when you're interpreting slope. The first one you want to remember is you always want to say something about when x increases by 1, and then you'll talk about what happens to y, and that will be your slope. So you can think about this. Remember, slope is a rise over run. If I put a run under here, a 1, this says the rate of change of y is 0.03 when x increases by 1. So slope is always over 1. Kind of like miles per hour is 1 hour. So when we talk about interpreting slope, we always want to say when our x increases by 1, our y, in this case, increases by $0.03 per month. So we're going to say, instead of x, we're going to say when data usage, which is our x-axis, excuse me, when data usage increases 1 megabyte, what happens to the cost, which is our y-axis? Cost increases because our slope is a positive number. So cost increases 0.03. Those are dollars. Your y-axis is dollars, so put some units on there, per month. So the rate of change is $0.03 per month. When data usage increases 1 megabyte, cost increases $0.03 per month. Okay, write an equation that represents the line as a function of data usage. Well, we know our slope, and we know our y-intercept, which is b, and we said that was 20. So y equals mx plus b. Oops, sorry. Let you copy that. So y equals mx plus b. Your slope is 0.03. That's what we figured out up here. Your y-intercept is 20. Or you could say cost equals 0.03d, which stands for data. So the D stands for data, the C stands for cost, plus 20. So these are identical. This one just is a little bit more like the context of the problem. Okay, the next one is your turn. I think I'm going to give you one little hint before you start this one. So this says an electrician charges an initial fee of $50 and $140 every 4 hours of work. So 140 for every 4 hours of work. That sounds like a rate. $140 every 4 hours. That is a rate. And I want to remind you that rate is the same as slope. So I've sort of really helped you out here. Sorry you couldn't see that. Rate is slope, so your slope is 140 over 4. Now you can simplify that because 140 divided by 4 is 35. Okay, I'm going to see if you can find the y-intercept, write an equation, and maybe answer those 2 questions. I'm going to tell you to pause the video and work on that one. Okay, we'll go over that. So I told you this, that $140 per 4 hours is a rate, so that is your slope. Your y-intercept is 50 because the initial fee is at the beginning. You pay $50. This is like the fee they charge just for them to come to your house. So $50 to come to your house, that's at the beginning, or when time equals 0, before they actually start working, you're paying $50. And then after that, you pay $35 for every hour that they work. So here's your equation, y equals mx plus b. How much does the electrician charge per hour? Well, that's your slope. $35 per hour is what they charge. 140 for 4 hours simplifies to $35 per hour. And then this says use the model to predict how much the electrician would charge if they worked 8 hours. So hours are your x. So here's my equation. If I substitute 8 for the x, so remember, wrap up your x, throw out your x, insert an 8, put all that in your calculator, you get $285. So for 8 hours, you would pay $285. That is the end of 4-1.